So here's a little bit different problem. We're asked to find the pH of a solution of weak base, NH3, and we know it's going to act as a weak base because we are given a Kb in the problem. So first thing we want to do is we want to set up the equilibrium that the NH3 is going to have with water. Now, because it's a weak base, it's going to act as a weak base with the water. And that means that the water is going to be acting as an acid. And so we're going to have, we're going to have NH3 plus H2O. It's going to be given to NH4 plus, that's the base, taking an H plus away from water. And when that happens, the water is left as an OH minus. We're going to go ahead and we're going to icebox this. And we know we've got 0.55 molar NH3 to start, no NH4 plus, no hydroxide. Some of that NH3 is going to get turned into NH4 plus, but I don't know how much. So that's minus X, and then plus X and plus X for the NH4 and the OH minus. Again, that E line is just the sum of all of those, and so I have 0.55 minus X, X, and X. So now I've got my equilibrium concentrations there. Okay, so let's write out our equilibrium constant expression. We have Kb is equal to 1.8 times 10 to the minus 5, and that's going to be equal to concentration NH4 plus times the concentration of OH minus all over concentration of NH3. Okay, we can plug all that in, and so we have, I'm going to go ahead and shift down here. We have 1.8 times 10 to the minus 5 is equal to X for the NH4 plus, X for the OH minus, and 0.55 minus X for the NH3. Now, once again, we're going to look at this concentration of, or the value of the Kb. It's very small, and so the amount of NH3 that actually we lose to NH4 plus and OH minus is going to be fairly small. So we are just going to ignore that X that's being subtracted, and so this is going to be approximately equal to X squared over 0.55. And once I do that, that equation becomes fairly simple to solve. I get a value of X that's equal to 3.15 times 10 to the minus 3. And you can see that that is, in fact, much smaller than 0.55. Now, when we look at what X is actually equal to, we see that X here is actually equal to the concentration of hydroxide ion. And so with that, we can take a pOH value. So a pOH is going to be equal to the negative log of 3.15 times 10 to the minus 3. So we get a pOH equaling 2.50, and our pH is going to be 14 minus 2.50, which becomes equal to 11.50. So we were given a Kb, we expected a basic pH, and that is in fact exactly what we got.